So from the okay. So I want to believe you can see my screen now. So for the topic that we said, we want to look at coordinate geometry of a straight line, and major thing that I want to look at there, we want to talk about points, points and distances. So when we have points, we have distance. What I'm trying to say here is that if you have our Cartesian plane, so in this case, we say this is y axis, this is x axis, and in this case now, if you have points, we may have this place as a point. This is also a point. So in such a case, the point, for example, this first point here, we may call it A. And that A is maybe x1, y1. So we also have point B. We can call it x2, y2. So in such a case now, we can join them together to become a straight line. So in such a straight line now, so that's when we have a straight line. It means a straight line, we can form a line by joining 2 points, 2 or more points together. So by the time we join the 2 points together, then we'll be talking about distance. What's the distance between the 2 points? So, and that is what we mean by distance. So how do we get the distance? From here, I'm not interested in just giving us the formula. You should know how they have got that. What's the principle behind it? So, because for those of us that will still do something of this nature in our institution, you see from line, you are still going to circle. From circle, you go to other conic sections. You do parabola, hyperbola, ellipse. So, and in those ones, there are a lot of formulas. But when you know the basis, how are they deriving those formulas? You don't even need the formula again. Anytime you need it, you just go to how they have got it. So, in this case now, so our x1, y1. So this one means that this is our x1, and it means that this is one is what our y1. When you trace this one through down, it means this is our x2, and when you trace this up, this is our what y2. So in such a case, how do we get the distance? Now, from what you have drawn here now, if you bring that down here, so we have something in form of a triangle. We have something in form of a triangle like this. So this is x1, this is x1, this is x2. This one is, this place is y1 when you trace it here. And this place, when you trace from here, this one is what? Y2. So from there, it means we can get the distance from here to here. So if from here to here is that, like that, we have got it here. From here to this place is y1, and from here to here is y2. It means in between them it will be what? That's the subtraction. That will be y2 minus y1. So if from here to here too, it's x1, like we do in our physics motion. From here to here too is what? X2. So if you are looking for the line, the distance between them, it means it will be what? X2 minus what? X1. So that's just normal logic with that one, if you are looking for such distance. So now our distance AB is actually the hypotenuse. When you look at a right angle, if this is a right angle triangle, and how do you get your hypotenuse? Hypotenuse square from Pythagoras theorem. Hypotenuse square equals what? Opposite square plus adjacent square. So it means you are supposed to square this and square this, add them together. So that is what we mean by, I hope you get that. So we'll go to some questions here. But before we do those questions, we need to, I think we did not derive the formula. So from what we have done there, it means our distance. You can just say that our distance equals what? The first one, so distance square. If you say that the hypotenuse is the distance, so By the time you do that, what do we have? We have, okay, is it not better? Okay, sorry for, okay, so our distance formula, okay, we didn't write distance formula there, so it means our d squared will be, that's the hypotenuse square, will be equals to what? Opposite square. The opposite that we could see there is y2 minus y1 squared plus opposite square, that's x2 minus x1 squared. So that is our formula. So, but by the time you are making d set of formula, because that's d square, so it means d will be equals to what? Square root of y2 minus y1 squared plus what? X2 minus x1 squared. So the square root. So that's the usual distance formula that you know. So from that one, if there's anything that is not clear, you can let me know. You can just call my attention. So from here now, if you haven't known the distance formula now, they said find the distance between the points. Question number 1 here. I will just do some there. I expect you to go and do the rest. This is like a revision class. It's only the SS1 that may just be learning this for the first time. So in this case now, find the distance. So for the question number 1, our distance will be equal to, just substitute. Pick your point. Which one is point 1? You can pick all this one as point 1, everything here as point 2. So it means if this is point 1, x1 will be equals to 2. And y1 will be equals to what? 5. If the other one is point 2, it means x2 will be equals to 5 and y2 will be equals to what? 9. So applying that, our y2 is 9 minus y1 is 5. Square that plus x2. X2 is what? 5. You can see x2 is 5. X1 is 2. So by the time you do that, so 9 minus 5 is 4. 4 squared plus what? 3 squared. That would be 4 squared plus 3 squared. And this is further math class. By the time we do that, we should be able to arrive at 5. 4 squared is 16. 16 plus 9, that's 25. Square root of 25 is 5. So 5, you write it as what? 5 units. 5 units. So that's the answer to that. So if you pick any other one too, it's same manner. It's same manner. So I want to believe that you can finish that up. Question 2, the same thing. In question 2, how do we do that? It means our D, let me just do question 2 before moving. D equals to square root of, that formula is there. I don't need the formula. Just apply it. I told you we don't actually award, it's not all about knowing formula alone, but know how to use that particular formula. So it's very, very necessary. So in this case now, if I pick this one as my point 1 and I pick this one as my point 2, so what happened? It means that by going by the formula, y2, our y2 will be equals to 2 minus y1, our y1 will be equals to 5. Square it plus the next thing, our what? X2. So what is x2? X2 is minus 3. Minus x1 is what? Minus 4. So that's making double minus. So 2 minus 5 will give us minus 3. Square it, minus 3 squared. Plus minus 3 minus 4. Minus 4 will become plus 4. So minus 3 plus 4 will give us what? That will give us, that's plus 1. So plus 1 squared. Square root of it. So by the time you do that, minus 3 squared will give us what? 9. Then 1 square will give us what? 1. So that would be what? Square root of 10. So that's square root of 10. Okay, let me see if I can write it clearly like this. Okay, square root of 10. So that's the answer to that. So can we move to the next? Sorry, I can't write that 10 clearly. Okay. Yeah. Square root of 10. So that's the answer to that. So let's go to the so you can do the rest. You can do the rest. So I will leave remaining questions for you to go over it. So number 5 and number 6. Also, should be able to do it. So it's part of some things that you have done before. So maybe I'll have to post the menu on Edmodo so that you give me solution to them there. Okay, so let's move to the next slide. So division of a line. Now, in division of a line, we can talk of that in 2 different forms. Division of a line. We can. Hello, can anybody talk to me there? Are you there? Hello? Are you with me? Okay. So when we are talking about division of a line, so if I have a line, division of a line, we can divide into 2. Division, it can be what? Division into equal. Okay, division into equal halves. Yeah, thank you. Division into equal halves. So that is talking about midpoint. So I may have a straight line now, and it's divided into equal halves, meaning I'm talking about the midpoint, A and B. And this is the midpoint. Sorry, let me see. Can I have, okay, this is razor. Okay. Yeah. So if I have division like this, I'm dividing into midpoint. We are talking about midpoint. So in this case, if I have this is the midpoint of line AB. So it means they will be divided into 2 equal halves. So that will be ratio 1 to 1. So if this is a Cartesian plane, and this is 0.1, 0.1, 0.2. So if this one is my x1, this is my what? X2. This is my what? Y1. This is my what? Y2. I will also produce something of this nature. If I produce something of this nature, okay, do we even need that? We don't need that self. Okay, we may not even need that. Yeah, so we may not need this. Let me just need that. Okay, so if you have something of this nature and you are dividing into equal halves, 1, 1. So if you trace this down, trace this one too down. Trace this one too down. So if you trace this one too down, you can call it a particular point. Call it maybe X. If you call it X, trace this one to up, call it Y. That's the what? Coordinate of the midpoint. So it means the coordinate of the midpoint is what? X, comma Y. So in this case now, how do we find the value of our X? How do we find the value of our Y? Exactly. So since they are divided to 2 equal halves, it means their ratio is just the same. It's ratio 1 to 1. Exactly. So if it is ratio 1 to 1, we can now say the distance from here to here must be equal to the distance from here to here. So what's the distance from here to here? From what we have learned earlier, it means if you are finding the distance from here to here, it will be what? X2 minus what? X. If you are finding the distance from here to here, it will be what? X minus X1. So this distance is what? X2 minus X. This distance will be what? X minus X1. The further one minus the what? The closer one. So that is it. So you equate them. When you equate them, we have x2 minus x equals to what? X minus x1. Make x the subject of the formula. If you make x set of formula, this x, put it there. Bring this one here. We have x2 plus x1 equals to what? 2x. Divide both sides by 2. So it means that our x will be equals to what? X2 plus what? X1 over 2. Likewise, our y2 will also follow the same format. It will be y2 plus y1 over 2. So hence, the coordinate of midpoint, if our midpoint is x comma y, our coordinate will be equals to what? x2 plus x1 over 2, comma y2 plus y1 over 2. So that's the coordinate of the midpoint. So that's the coordinate of the midpoint. How you get coordinate of the midpoint? So let's use that coordinate of the midpoint to solve some questions. So we use that, the coordinate of the midpoint, to solve some questions in the next slide. Okay, let's move to the next slide. So we have these questions. We said state the coordinate of the midpoint of the following, of the line joining this. So this one too is very straightforward. I'll just do one and leave there. I'll do one and leave there. So we have, so you can just ask yourself which one is point 1, which one is point 2. This is point 1, if this is point 2. From there, you can pick, what's the formula? Let P s comma y be the coordinate. So what will be the formula? That would be what? X2 plus x1 over 2. Y2 plus y1 over 2. So that's the this thing. So if you apply that, in that case, what is your x2? If this is point 1, this is point 2. So our x2 will be equals to what? 4. Our y2 will be equals to 7. So x2 is 4, x1 is 2, divided by 2, comma, y2 is 7, plus what? Y1 is 3, divided by 2. So from there, we have 4 plus 2 is what? 6. 6 divided by 2, 10 divided by 2. And that's what? 3,5. That's the midpoint. So you can do that for the rest too. Just add them point-wise or coordinate-wise, and divide each by 2. So that's I hope there's no problem. If there's any question, you can let me know on time. So the next, so you can complete the rest. The next one is what? Division of a line, the second one. We want to divide a line into what? Into ratio, a given ratio. The one we did there is just what? Into 2 equal halves. So that's what we call the midpoint. So it's dividing them. So in this case now, we want to look at if you are dividing into what? If you are dividing into a particular ratio. So for example, now let's say we have a coordinate, if you have this, sorry for that line. So in this case now, you have line AB, and in this case, we are dividing into a particular ratio. Let's say ratio M to N. Ratio M to N. Maybe this one is M, this is N. So our M sometimes can be 3 and our N be 2. It could be, so in this case, we say we divide into what? Internal and external division. Internal and external division. So we are still talking about internal division. So we'll still talk about this thing later. External, when you divide externally. So this is still internal division. So this, we can call this one point P, which is dividing it internally. You can see it's internal. It's dividing it internally. into what? Ratio m to n. So what do we do here? How do we get the same procedure we use for the other one? You see the same procedure we are going to use now. So what we just do is what? Your x1, trace it, x1, trace this one, and y1, trace it. Trace this one too down, we have x2. Trace this one up, we have what? Y2. So we haven't done that. In this case now, if you trace this one down, if this is point P, let this one be what? X. If you trace this one, let this one be what? Be Y. But in this case now, they are not equal. We can't say this and this. From here to here, it's not equal to this, but they are in a ratio. They are in what? In a ratio. So what do we do? In this case, when you find the distance from here to here, find the distance from here to here too. From what we have done so far, distance from here to here will give us what? X minus x1. Then the distance from here to here will give us what? X2 minus x. So that is it. So in such a case now, we can now say since they are in what? In a particular ratio. Since they are in a particular ratio. So you just say that, ratio can also be expressed as what? As a fraction, a rational function. So it means in this case, we can say that this, the first one, ratio of this to this is equals to what? M to n, or you express them as fraction. So when you are expressing them as fraction, if you are taking this one first, it means you are going to have x minus x1 over x2 minus what? X must be equals to what? You have to take AP first too. Must be equals to m over n. So you can cross multiply there. When you cross multiply, you have n x minus x1 is equals to what? M x2 minus x. X2 minus what? X. So if you do that, expand. So we have nx minus nx1 is equals to mx2 minus what? Mx. Bring anything with x together. So this one has x, this one has x. Bring them together. We have nx plus mx equals to what? Mx2 plus what? Nx1. So x is common. If x is common, it means you'll be left with what? So we have n plus m left here equals to what? Mx2 plus nx1. So you can divide both sides. So our x will now be equals to what? Mx2 plus what? Nx1 over what? N plus m. So that is the value of x. So likewise, our y will now be equals to what? My2 plus ny1 over n plus m. So that is how we can what? We can get the point that divides what? That divides a line into what? Into a given ratio internally. I will show us in the next slide, I will show us how we can do that of external division. But in external division, I may not tell him, I will just tell us what we mean by external division. Then how can we differentiate it? I may leave you to go and prove external division the way we have done it like this to get your answer. I will tell you what you should get as your final answer. So that's what I'm going to do for you. I'll tell you what to get as your final answer. I won't do that. I'll just give you the idea. So you go and do it. I'll tell you what you can get as the final. So I think we can move on. So that's the formula. So in the next slide, we can write out the formula so that subsequently when you want to use it, we know how to use it. Can I move on? Is there any question before I move to the next slide? Okay, so it's like there's no question. So let me move on. So I have this question. Before I treat that question, from what we have said now, you can say that what coordinates P, S, Y of a midpoint of a point that is dividing into ratio m to n. It means the formula will be equals to what? mx2 plus nx1 over what? M plus n. Then for y, it will also be what? My2, the same format. My2 plus what? Ny1 over m plus n. If you like, you can put it as n plus m, whichever one. So that's the formula. So we have this. Okay, this question, if you look at this question, given that A and B, given A and B, given that A, B as the point 5, 2 and minus 3, minus 6 respectively. Find the coordinate P. If P divides AB in the ratio 3 to 5, minus 3 to 5, minus 5 to 3. That's minus 3 to 5, minus 5 to 3. Those ones are what? External division. In external division, yeah. When we say external division, let me just tell you, for example, if you have AB, this is point AB. If you have anything to divide this one externally, it means that point will come here, it will be outside. So that's why some people, when they want to represent it, they will use what do we call it? They will use we call it T-continuous line. So it will, or dotted line. Okay, sorry. So okay, yeah. Okay, so they will use T-continuous line. So like this, something of this nature. So if this is point P, so they will say point P divides AB externally. It divides AB externally. So when it's dividing, it means the major thing that you have to do here. What they mean is that, so they will now write it in what? In negative, in negation, you can see. So this one could be 5 ratio 5 to minus 3, for example, or 5 to minus 2. In such a case, it means what they are saying is that from here they will pick, in the other one too. In the other one where we have AB and P divides, we are particular about P to A, then P to B. So here too, it will be P to A, P to B. Exactly. So if they say this one is 5, ratio 5 to minus 3, for example, it means from here to here is 5. And the remaining one here, this one is coming back. That's why it is negative. 5 will be A to P will be 5. But because it's also coming back, that's why it's having negative number. So it may be minus 3. So this one will be minus 3. Or you write it as 3. If you write it as 3, the negative is just that is coming back. PB. It is AP, PB. So AP, PB will come back. So it's not following the forward direction you are talking about before, but it's following it backward. So an invectors, it should be negative. So that's why we put it like that. So anytime you see, so that's the only thing that will just change. So it means the only thing when you do that, you can go and find it. Find what would be the formula, what would be the coordinate of s comma y, p, which is s comma y in such a case. So, but the formula you are going to get is that instead of having plus here, it should be what? Minus. So you can go and try it. So to be it should be in form of minus. That would be mx2 minus nx1 over m minus n, then my2 minus and so on like that. But like in this one that they have given us, we don't need to put it as minus again. Once you use this one as minus, it has taken care of it. So it means if you want to apply this formula, you just, so in this case now, for the second one, you just put your m as what? Minus 3, and you put your what? N as 5. So it's still this same formula you are going to use. So that is what you mean by that one. So in this case now, our we have 0.5 comma 2 and then point minus 3 comma minus 6. So, and then we are talking about ratio. Our m is equals to 3 and our n is equals to 5. So let me go to the next. Okay, I may not be able to go to the next slide. I didn't have an extra slide. Okay, so this is what you are going to do. So I will just clean the board now and solve the question. So so how do we solve that? We use that that same formula, and I don't want to clean. Okay, no problem. So okay, let me just leave this piece. So like I was saying, sorry. So from what I'm explaining, if you have to apply the formula, sorry. Okay, yeah. So in this case, if you apply the formula, our m is what? Our m is 3. So I'm going to have 3 into bracket x2. Our x2 is what? Minus 3. Plus n. Our n is what? 5. And our x1 is what? Is 5. Divided by what? M plus n as 3 plus 5. Comma, our y, m is still what? 3. Our y2 is what? Minus 6. N is what? 5. And our y1 is what? 2 over 3 plus 5. So we have minus 9 plus 25, minus 9 plus 25 over 8. That's 3 times 6 minus 18 plus 10, minus 18 plus 10. Divided by what? Divided by 8. So this one will give us 16 over 8. This one will give us minus 8 over 8. So 16 over 8 will give us 2. This one will give us minus 1. So it means the coordinate of point P for that question will be equals to what? 2 comma minus 1. So that is how we can do question of such nature. So in the next question, minus 3 to 5, you can all those ones. Just substitute. The value of x1 remain the same, x2 remain the same, y1 remain the same, y2 remain the same. The only thing that will be changing in the remaining two would be what? The values of m and n. For the second one, m will be equals to minus 3. Don't change any formula, the same formula you are using. M equals to what? Minus 3, and n will be equals to 5. The other one, m will be equals to minus 5 and n will be equals to what? Equals to 3. So that is where we are going to end the class. So I also have some questions here for us as assignment. Maybe if you can just, if you have any writing material there, you can just put it down. The question says that what? Let me read the question. Say P point P, which is the coordinate of P is what? Small p, comma 5. Lies on the line joining A. Coordinate of A is 1, 2. And B, coordinate of B is minus 4, 7. Question is find the ratio AP, P for pass, AP to PB, P for pass, PB. Then question B, find P. So let me take it again. It said P, this is the way they have written it, P, which is of coordinates, small p, comma 5, lies on the line joining A. A is and B minus 4, 7. Then find the ratio to PB. And the second question, find was small. So, any question? If there's no question, we can.
That was good. Jesse, where's that place downstairs? Look at that.